Hello AP Calculus, this is Mr. Fugay, and for this video we're going to talk about the first half of our next lesson, which is how to find limits algebraically. So we're going to start off with an idea here that is pretty straightforward, and that is when you're given an algebraic function and you're asked to find the limit, the first strategy you should always use, no matter the situation, unless it's a piecewise function, I'll write that in for you, is that we should try to use direct substitution, okay? So that should be our first idea, and then again, I'm going to say unless it's a piecewise function, which in the second half of the lesson, we'll talk a little about what to do in those situations. So when you do that, and to be more specific in terms of what I mean by direct substitution, is if I have a limit as x approaches 2 of x squared plus 4 over x minus 1, the first step that you should do is quite literally plug that 2 in. So you would get 4 plus 4, which is 8 up top. You would get 2 minus 1, which is 1 on the bottom. And quite literally, for this first problem, you would get 8 as an answer. Now, in that situation, that would be three things could happen. This would have been a scenario number 1, where if I take the limit and I do direct substitution, I get any number. I will note, by the way, that if you get 0 over a number, so like 0 over 5, 0 over 10, that is considered any number, okay? Considered any number, okay. In scenario number 2, sometimes you're going to be left with a number like 5 over 0 or 10 over 0 or 12 over 0 when you do that. What that's going to represent is a vertical asymptote. And in those situations, and there's, we'll talk about this in a different lesson at a different time, one of three things will happen. Either the function will do something like this, in which the limit then would equal infinity. It would do something like this, where it would equal negative infinity. And lastly, it could do something like this, in which the limit would not exist. But this video is not going to focus on either of those two situations. Rather, we're going to focus our attention on scenario number 3. What happens if we get 0 over 0? What this is called in math is an indeterminate form. So this is called an indeterminate form. And whereas the first two scenarios, I pretty much gave you what's going to happen in pretty much all those cases, in this, we're going to need to do more work in order to get our solution. So those are the three scenarios we're going to be looking at. To be a little more specific, here it is again. If you get any number, you are done. In scenario number 2, if you get a number over 0, there's a vertical asymptote. So the limit would not exist. Now, I want to be more specific with that, because remember, there are going to be situations where it would equal infinity or negative infinity, and while those are technically not numbers, so it technically means limit doesn't exist, we want to use those descriptors to give us more information in those two scenarios I mentioned just a moment ago. And then lastly, of course, if you get 0 over 0, that means more work. And this video is going to focus on 3 particular examples in which we can do that. So in those scenarios, essentially what's happening here is what we want to try to do is to simplify this expression by essentially trying to remove what could be a possible hole from the graph and identify where that hole is, and then therefore what the limit's going to be. So these are the 4 main strategies we're going to look at, and here they are a little more specifically. This video, we're going to focus on simplifying rational expressions. We're going to look about multiplying with conjugates, and we're also going to look at complex fractions. So we're going to look at those 3 examples in what we would do in that situation. So let's take a look at our first example. Here it is. The limit as x approaches negative 2 of x plus 2 over x squared minus x minus 6. So in this, again, as I mentioned in the very beginning, the first thing you should always do is try direct substitution. Negative 2 plus 2 is going to be 0. Negative 2 squared is 4. 4 plus 2, because it's a negative, minus 6 is going to give me 0. So what we have is that indeterminate form. So what I have to do here is I have to try to find a way to simplify this. And so looking at the denominator, I see that I am able to factor that denominator because it's a quadratic in a trinomial form here. So this is going to be, let's see, 2 numbers that multiply to get negative 6 but add to get positive 1. I believe that's going to be plus 2 and minus 3. And what we should see here is with this new simplification that we can eliminate the x plus 2, and we'll see that this expression equals 1 over x minus 3. Therefore, we're now going to reevaluate the limit using direct substitution using this new simplified format. So when I do that in this case and I plug in -2, I'm going to get -2 minus 3 down in the denominator. So the limit here is going to equal -1/5. Now if you're wondering what's happening graphically here, is what we did is we identified that there was a hole at -2. And so that's essentially what this is doing. We're removing that discontinuity and then identifying what the value would be when we look at it on the graph. So that's our first example. Let's take a look at a different example where we're going to have the same problem, but we're going to have to try a new strategy. And here it is. So in this case, we have the limit as x approaches 16 of this. So if I plug this in, the square root of 16 is 4, and 4 minus 4 is going to give me 0. Down in the denominator, I'm going to get 16 minus 16, which is also 0. So same problem, different story here, because we need to now try to figure out how we can simplify this problem. So in a situation where we have radicals involved, as opposed to squares and quadratics like we did in the previous example, what we need to employ here is another algebraic strategy to try to help simplify or rewrite this expression. When we're looking at a radical like this, what we want to do is multiply by its conjugate pair. So the conjugate pair of square root of x minus 4 would be the square root of x plus 4. The purpose of doing that is that the numerator is essentially going to, because you're only going to be multiplying with the difference of squares, you're only multiplying the root x to the root x and the -4 to the +4. Therefore, there will be no more radical in the numerator. And there's a reason behind that, and we'll get to that science in just a second. So, all right, so we multiply by a conjugate pair. You have to do the same thing to the top and the bottom because that's the same as multiplying by 1. In the numerator, we're going to get root x times root x, which is x. We're going to get -4 times +4, which is -16, which is extremely helpful because what I'm going to purposely not do is I'm not going to FOIL that bottom because, as you are probably seeing now, we can cross out a common factor. And I'll be clear, if we're using this 0 over 0 strategy, something needs to cancel or eliminate. Something needs to cancel or eliminate, or this will not work. So my new limit as x approaches 16 is going to be 1 over the square root of x plus 4. We're going to go ahead and redo that substitution again, that direct substitution. We're going to get 1 over 4 plus 4, which is going to give me 1 over 8. So there's my second example. 1 over 8 is my limit. And for our last example, we are going to take a look at a situation where we're going to have to use complex fractions. One little typo I need you to adjust for me is instead of that plus sign, if you could put a minus sign right there, that would be great for this problem. So as we've been doing in all of the other examples, we need to do direct substitution. So when I do that, we're going to get 1 over 3 plus 1, which is 1 over 4, minus 1 over 4, and then in the denominator, we would have gotten 3 minus 3, which is 0. So once again, we're going to get 0 over 0 as our indeterminate form. So from here, we have to try to figure out, well, how can I simplify an expression with complex fractions? There's really a couple different methods that students use for this. What I have found to be the most popular is the complex fraction is occurring in the numerator. And so the question is, what number could I multiply to the numerator to eliminate the fraction? Well, that would be what the common denominator is, which in this case would be 4 times the quantity x plus 1. So if I multiply the entire numerator by 4 parentheses x plus 1, I will eliminate the first fraction of x plus 1 because those factors will cancel, as well as the 4. Of course, whatever you do to the top, you must also do to the bottom, so let's go ahead and take care of that next. So from here, when I distribute the 4 and x plus 1 to this first term, the x plus 1s are going to cancel, which leaves me with just a 4. When I multiply this term to the second number, the 1/4 here, the 4s will cancel, leaving me with a minus quantity. Be careful with your parentheses here, x plus 1. Down in the denominator, I'm going to not multiply any of that stuff out because once again, like we've done in the first two examples, we're hoping something's going to cancel out. So let's continue simplifying this expression here. Remember that this is going to be really minus x minus 1 when I distribute this. So it's going to become negative x, 4 minus 1 is positive 3, over 4 parentheses x minus 3, x plus 1. Now, you'll notice that there's technically in its current form no terms that are alike. However, these two terms are very, very, very similar because if I factor out a negative 1 out of this, this would become x minus 3. So that's exactly what I want to do here. So this x minus 3, not the negative, keep that in mind, and that x minus 3 would cancel out, leaving me with the final simplified expression of 1 over 4 quantity x plus 1. Remember, if factor or term does not cancel out, then you're probably going to get 0 over 0 again. So because that has canceled out, this is now time for me to go back and test my problem. So this was the limit as x approaches 3 of negative 1 over 4 parentheses x plus 1. We're going to go ahead and plug that in. So we get negative 1 over 4 times 4, and that's going to give me an answer or a limit here of negative 1 over 16. So go back to this video if you need to look and review over this, but we talked about 3 different strategies to try to simplify an expression when you get 0 over 0. First, through factoring, then through multiplying by the conjugate pair, and then lastly, simplifying a complex fraction. So I hope this video has been helpful for you. Feel free to go back and rewatch any bit of it, and good luck in your practice, everyone.